Hello class, and welcome to Mr. Leader's the Leader's Edge Math channel. Today we're going to be learning about how to graph polar equations by hand and how to change them from polar into rectangular form. So the first one we have here is r equals 3. And all that means is that the radius is always equal to 3. And so if you go out to 3 this way, and since the radius is always 3, and it doesn't matter what theta is, that is the same as graphing a circle with a radius of 3. So there's not that much to this one. So if I were to make a circle here with a radius of 3, that would be that graph. That's pretty easy, ain't it? Okay, so then if I want to change this into rectangular form, remember that r is equal to the square root of x squared plus y squared, and that means in this case that 3 is equal to the square root of x squared plus y squared, which means if I squared both sides that x squared plus y squared equals 9, which is a circle with the center at 0, 0 and a radius of 9. Okay? Pretty easy, I think. Okay, next one, and you should have this note sheet in front of you. Theta equals pi over 4. So what that means is that the angle, no matter what the radius is pi over 4. And so if I were to go on my polar graph, remember this was pi over 3, this was pi over 4. Okay? So the angle is always pi over 4, so all that is a line that that follows. Oh, that's a blue line, that's okay. That just looks like that. Now, if you graph that on your graphing calculator in polar form, that's probably what you would get, although I think you have to have it in terms of r to graph it in polar form. But in any case, how do I change that into a rectangular equation? Some of you may already know that the equation that is y equals x, but I'm going to show you how we get that. So if you remember the tangent, what we learned yesterday, the tangent of theta equals y over x. Okay? And so we know in this case that theta is pi over 4. And we know that the tangent of pi over 4 is equal to 1. And that's got to be equal to y over x. So multiplying through by both sides by x, I get that y equals x. Isn't that easy? Yes, it is, Mr. Leader. Thank you. Hey, put that cell phone away. Yes, you. Just kidding. Okay, now moving on. I don't have any good jokes for you today. I might pause it and look for one, though. Okay, so moving on to the next problem, boys and girls. We are going to do this one, and I'm not going to do this one as well because it's kind of the same thing, and this one's pretty similar, but let's do this one. So this one also makes a circle, okay? And so if I were to graph this by using polar form, r sine theta equals 2. Hold on. Going back, I was wrong. I said this was a circle. It's not. R sine theta equals 2. This is like saying I would first convert this to rectangular form, because we learned yesterday that r sine theta is equal to y. So that's the same as saying that y is equal to 2. And so it's a line that is up here at 0, 1, 2, and it would be horizontal to the or parallel to the x-axis. So that's the line r sine theta equals 2. If you want to plug in some values and see if that is true, okay, we could plug in like let's see, let's plug in pi over 6, for instance. So if I go r sine of pi over 6 equals 2, okay, then, and I want to find r, so we remember that sine of pi over 6 is 1/2, right? So you get r times 1/2 equals 2, which means that r would be equal to 4. So if you look on that graph, if I come out here to 1, 2, 3, 4 and rotate through an angle of pi over 6, that would put me right on that line. So that's kind of how you could graph it by hand, but really what you should do with this one is just change it into rectangular form first. Likewise, this one is also a line, and we remember that our cosine theta equals -3, so this is like our cosine theta equals x, so this is like saying x equals -3, and most of you remember that this would be a vertical line which goes through -3 like that. Okay? Easy. Alright, so this one, the next one, class, is a circle, and I know it's a circle because it says circle there. No, that's not really why I know. I just know this form. But r equals 4 sine theta. So if you actually wanted to plot a couple points, we could do what we did in the last problem, like plug in a value for theta and then determine r. And so like here's theta, here's r, and then I would plug in, for instance, theta is 0, and I get 4 sine of 0. We know that the sine of 0 is 0, so I get 4 times 0, and I get a radius of 0. If I were to plug in pi over 6, okay, I get 4 sine of pi over 6, which I know is 1/2, so I get a radius of 2. So what that means is out here I go out 1, 2, and then rotate through pi over 6 and put a point there. And you might think, oh, it's just a circle with a radius of 2, but that's not what you're going to get, because when I get here to pi over 2, for instance, okay, and I were to plug that in, sine of pi over 2 is 1, and 4 times 1 makes 4. So what I get is I would come out here 1, 2, 3, 4, and I rotate through pi over 2, which gives me a point there. And you might say, oh, that doesn't look like a circle, but it does. It just has its center somewhere else. To see what that circle looks like, I'm going to change it to rectangular form. Okay, so I'm going to grab this here, and I am going to change this equation into rectangular form. And I believe we did this yesterday with the class, but what you want to do with this is multiply both sides by r. So I'm going to multiply this by r, and I'm going to multiply this by r over here, but I'm going to, so that gives me r squared, and the r I'm going to put between the 4 and the sine theta so it looks a little more friendly. 4r sine theta. Okay, so r squared equals 4r sine theta, and what we did yesterday, we wrote r squared as x squared plus y squared equals 4 times r sine theta is y, and then I have to bring everything on one side and complete the square. So the way I do that is by going x squared plus y squared minus 4y equals 0. And then I don't have to complete the square on the x part, but I have to complete the square on the y part. So y minus 2. I take half of the linear term, that's called, and I square that. And when I did that, if I FOILed this out, I would get y squared minus 4y plus 4. So what I've essentially done when I've done this is I've added 4 to the left side of the equation. So to keep the equation balanced, I need to add 4 to the right side of the equation. And then what I get is the equation of a circle. The equation of a circle, if you remember, is x minus h squared plus y minus k squared equals r squared. So this equation is actually the equation of a circle with the center. HK is the coordinates of the center of the circle, and r is the radius of the circle. So the h is 0, so that means that the center is at 0, comma 2 with a radius of 2. So if I go up 0, comma 2, and I draw in a circle that has a radius of 2, I'm going to try to do that with my fancy circle tool. Okay, I'm going to make it red this time. And let's see if it goes through those 2 points, which it kind of does, that I plotted earlier. Don't worry about that little mess up there. Can I get rid of that? I did. And there you see what the graph of r equals for sine theta. Now what I don't want you to do is plug this into your graphing calculator, but I'm not sure if I showed both periods how to do that. But if you go to your TI graphing calculator, being the high technology teacher that I am, I will hide this. Okay, and whoops, I already did that. R equals 4 sine theta. Now when I did that, before I did that, I went to mode and I made sure I was in polar form. And the other thing that I did is I set up my window to one that makes sense. So my theta is 0 to 2 pi, meaning I want to go once around the circle. My step, I think that comes up automatically. And then the x min and max min, I just set that one from -6 to 6 for some reason, and the y from -4. Oh, I remember what I did with this one. If I went to zoom 6, which is a standard viewing window, I get kind of a squished looking, oval looking thing. And the reason for that is because this is the spaces are not evenly spaced. To actually see the circle, I have to go to zoom square, which is number 5, and that gives you a square viewing window, and so then you can actually see what the graph of that thing looks like. Okay, and it should be a circle, and I could zoom in or change my window a little bit to make it better. Zoom in, okay, to enter, so you get the idea, right? Whoops. Okay, so anyway, one more type of problem that you're going to see in tonight's homework class, going back, and that's going to be this one. I think you can handle. It's just like this one, except it's going to be centered on the x-axis, probably over here somewhere. And we'll talk a little bit more about the general forms of these. But the other type of thing that you're going to see, and this one isn't on your handout, is something of the form r cosecant theta, momentary senior moment there. Cosecant theta equals 9. Okay? And you see this and you say, I don't know what the heck to do with that. Well, what if you remember from before, cosecant is equal to 1 over sine theta, which is equal to 9. Okay? And so then you multiply through by sine of theta, and you get r equals 9 sine theta, which looks very much like the last couple problems. So then you would square both sides, or multiply both sides through by r, 9r sine theta, and then you get r squared equals 9y, and then you get x squared plus y squared equals 9y, and you could do the rest. Okay? So if you see something like that, cosecant or secant, that's what you do with it. Okay, so tonight's homework is just what's on the bottom of the sheet, and then on Monday I'll talk to you more about these interesting shapes like cardioids and limaçons, and a rose curve, and what else? And little spiral thingies that this one does, and this does something with loops in it, and all kinds of interesting shapes. But for tonight, that's all you have to do is 597, 1 through 8, 13 through 40, every third problem, 13, 16, 19, etc. Just keep going until you get to 40, if that's where it ends up, which I think it does. And remember, you heard it here on Mr. Leader's Roller Derby and Math channel. Okay, thank you. Good night.